Welcome, my name is Derek, and today we are going to talk about Retrieval Augmented Generation, RAG. This is in the context of generative AI, so AI ML, and leveraging Spring AI. And imagine the use case where you are a company. In this case, we'll call ourselves Acme Insurance. You have a wealth of internal knowledge and data that is not out on the internet. This might be data about your policies, it could be Q&A or help information, and you might want to make this information available internally to your employees or to your help desk agents so that they can help customers, or you might want to make it available to your customers so they can have a chat with an AI agent to gather this information. The challenge is all the major models from ChatGPT, Anthropic, Gemini, etc. are not trained on your data. They don't have your data, which is a good thing in one way. But if you want to expose that data to one of those models, or perhaps a model running on your own infrastructure, something like Ollama with Llama 3, you need to bring that data to your model. Like, you don't need to build your own model. You don't need to train your own model. You simply need to bring your data to that model. And there are really two ways of doing this. One, we've talked about in a prior video, is function or tool calling. And the other is RAG, Retrieval Augmented Generation. I'll point you to the other video if you are interested in function or tool calling. But today we are going to be looking at RAG. So with RAG, what you're doing is you're augmenting your query, your prompt. So in a typical scenario, you would put in your AI ML request, and that prompt would be sent to the model, and you would get a response. Here, what we're going to do is we're going to take the information, the documents and data that we want to enhance the model with, so our information, we are going to embed that and store it in a vector store, a database. And then whenever a request comes in, we are going to do a search of the vector store, a similarity search, find the relevant data, and then pass that along with our query, with our prompt to the model to get a response. So if I'm a customer support agent at Acme Insurance, looking to find out details about our auto policy, my question or my prompt might be, tell me the information about this auto policy. We would do a vector search to find relevant policy information. Those would be the chunks. We would take that plus my query, tell me about auto policies, and then we would send that to the model. The model would then use its knowledge plus the additional information we've provided to then send me a response. And I'll call out, this is different than tool or function calling because this is very static data, right? This is documentation, help desk, Q&A. Tool calling is very much for real-time data. So give me the most recent stock price, right? Give me the time, give me the location, or could be transactional operations like buy a policy or cancel my policy. Those would be more appropriate for tool calling, but larger data sets that are fairly static is great for RAG. The other portion that we'll touch on briefly here is just how the data ends up in the vector store. That's the other half of this picture. I'm not going to go into details here, but you'll need a data pipeline that is taking the data from where it lives today, your internal databases, data stores, whatnot, and then writing that, embedding it into the vector data store. We will do this in a really simple example to take some static data and write it in there in the example, but we won't build out this full pipeline. So with that, let's go ahead and jump into the code. We're going to go back to our existing AI application that we started with start.spring.io. And this is a simple chatbot here. I have it running against Ollama running on my laptop. And what we can do is a simple request. So here we can say, who is Acme Insurance? And I would expect it will have no idea who Acme Insurance is, but let's see. Yeah, Acme Insurance is not a well-known or established insurance company. I don't know who it is. I mean, we can also say like, what is the best pizza in Chicago? Wow, that's going to be a controversial one. But hey, we can do a general query just to show you this is right now. This is just a general chatbot, right? And it gives you Luminati's, Uno, and a couple others. So we've got this running. Let's go ahead and add RAG to it. So I'm going to go ahead and stop the process. And to add RAG, we need to do two things. Number one, we need to configure RAG and the vector data store in my application. And we also need to run a vector database. And we're going to do so locally. There are many vector databases out there. Pretty much any database out there now supports vectors, be it SQL, NoSQL, or otherwise. Neo4j is a common one. In this case, we're going to use Postgres with its PG vector extension. So let's go ahead and start adding this. And with all things Java, Spring, Gradle, we're going to start by adding it to our dependencies. So the first thing we're going to add here are the Spring starters for Spring AI to enable vector data stores as well as PG vector. So let me grab these and I'll paste them in. So this is the generic vector advisor and then the one for PG vector. Now that we've added those, let's go ahead and run a clean build to go and make sure we've got the latest dependencies. This may fail on the tests as we've not actually added a vector database. Not surprising. That's okay. We've got it started. We will add that to the tests here in just a bit. But let's go ahead and go to our main class here. And this is the main class where we are creating our chat client. We are adding the memory and logging advisors and exposing it as a REST endpoint. If you haven't watched the previous video on getting this set up, please go and watch that. But what we're going to do is enhance this to add RAG. So the first thing we need to do is add a vector store. So we will add a vector store called vector store. Spring will auto wire that. That's the beauty of using Spring and Spring AI. And then we are going to add a new advisor here, if the help will get out of my way. So this will be default advisor. And what we want is a question answer advisor. This is what is providing RAG. And in here we will provide our vector store. We need to build it first, sorry. We need to builder with our vector store dot build. And we ended up with the extra parenthesis down there. So this injects our vector store and this adds our default advisor, which will pull in the information. I'm going to save this. And then I want to show you what happens if I go ahead and try to run this now. So let's go ahead and run it. I'm expecting this to fail because we don't have a vector store. And the beauty of Spring is saying, hey, I don't have a URL for the database. I can't find an embedded database. You got to give me a database if you want me to work with this, or a vector store. Makes sense? So let's go ahead and add that vector store to make it happy. So like I said, we're going to use PG vector. For doing my development, I'm going to use Docker Compose. That way I can run and have Spring run PG vector right on my laptop in Docker. For testing, we'll come back to that. We're going to use test containers. But let's just get started with running it on my laptop, and then we'll get back to my JUnit tests. So I'm going to need to add a little bit more for my dependencies, and we're going to add these two for development only, Docker Compose and Spring AI with Docker Compose. We will save that. And I also want to set a couple of new application properties. The first one I want to set is I want to tell it that for doing the embeddings, so when it takes my documents and embeds it into vectors to put in our vector store, I also want to use Llama 3.1. And then to configure our vector store, we're going to add a handful of properties. So we're going to configure PG vector. We're going to have it initialize the schema. We need to do this. It'll build out our schema for us. I'm going to turn off indexing for now. That would be a future performance enhancement, but it gets a little bit more complicated there with how many, basically columns, how many dimensions you have in your vector. We're going to set 4096 for the dimensions of the vector because that is what Llama 3.1 will give us when we do the embeddings. I'm going to give it a default URL. That may not be necessary, but sometimes it is. And then for Docker Compose, I'm going to tell it, hey, go ahead and start and stop my Compose images as I run this. So let's go ahead and save that. And let's just go ahead and try and run it. I may need to run a new build, but hopefully it picked those up already. Yeah, connection refused because I don't have a Docker Compose file. So let's go ahead and add that. So we will create a new file. This will be a text file. Go ahead and just save it first, compose.yaml. And I will paste in here a boilerplate Docker Compose file. So standard Docker Compose, we are running one service, which is PG Vector. That is the image we are going to use. Got default database, username, password, and port. So that'll be enough to give us Docker Compose. Save that. Let's run it again. And now that we have a Compose file, using Docker Compose file, I expect this to be more successful. All right, and we've started the application. Great, so we've got all the plumbing done. Now the important part is that we need to load some documents, load some information into our vector database. We are going to, again, do that from our main class over here. Of course, this would be a pipeline anywhere else. But so we will load data into our vector DB. And I actually asked ChatGPT to generate me some data for Acme Insurance about our insurance products. And I'm going to copy and paste this so you don't have to watch me type out all of this information. So what we're going to do is create a list. Let me go ahead and organize my imports to pull in a list and a Spring AI document. We're creating a list of documents. And then each document here is just going to be some text. ChatGPT generated me some interesting stuff to say, hey, Acme Insurance is in Park City. They have a platinum plan. They have a home guard policy. This is all fabricated information that's not on the internet, right? So it's not going to be in my model. So this will be stuff that we'll be able to see the model through RAG pulling in. So we've got this list of documents. What we need to do is take our vector store and then write this list of documents into it. That's it. So let's go ahead and run this again, because this is in the method that is getting initialized. It will execute. And we should see that it is pulling the vector table and running that information. So it should have encoded those and put them in the database. So let's go and see. Let's go back to our command prompt. And we can say, who is Acme Insurance? Let's just try a generic one for now. Okay, so it knows it's got some information. Let's go ahead and start asking it about Acme Insurance. So we could say, like, where is Acme Insurance? Hey, it's a US-based company, 1985 in Park City. That's what we told it. We could say, does Acme Insurance offer car insurance? Yes, they have an auto platinum plan. Right, not a ton of details here, but we only loaded a little bit of information in there. Let's try one more. What do customers think of Acme Insurance? We didn't put exactly this in, so let's see what it comes back with here in the prompts. Oh, that's impressive. Seems that Acme Insurance has a good reputation, Net Promoter Score 72, says customer satisfaction. That's pretty slick because I asked what do customers think, and it was able to, using vector math, vector proximity, determine that, hey, that is very similar to a Net Promoter Score. So let's go ahead and use that information to respond. So with that, we've shown the high level flow of setting up a vector store, embedding a set of data into the vector store as vectors, and then putting in a request that then retrieves information, doing a vector search in the vector data store, providing that plus our query as the prompt to the model, and getting the response. So one last thing I want to do here, and you're welcome to stop here if that's all you cared about, but I want to get the tests working. And for the tests, I want to use test containers. So let's see, I'm not sure, I don't think a build will work right now. So if I try to do a build, which is going to run my tests, I'm guessing it's going to say, you don't have a vector store because it doesn't know about Docker Compose. So it's saying failed. I could run it with debug or more information here, but the easiest way to see it is to come here to my tests. And let's go ahead and rerun the tests in VS Code. And we see an issue here, and we can see in the logs, connection refused. That's got to be my connection to the database. Yeah, pSQL exception, couldn't connect. So this isn't using Docker Compose. The standard with Java and Spring is to use test containers. So let's go ahead and do just that. So we'll come back to our build.gradle, and we are going to add test container. Now this looks like a lot. It's 4 different things, but really it's Spring Boot test containers, Spring AI test containers, and then it has a plugin for JUnit and a plugin for Postgres. So we can go ahead and save that. That is our dependencies. But in order to enable test containers for Spring AI, we have to do one other thing, which is we have to create a configuration class. So we can do Java, new Java file. This will be a class, and we want to call this test containers configuration.java. And I'm going to put in a little bit of boilerplate code here. So let's go ahead and format that. Go ahead and save it. It probably has not updated my build since that last build failed. So I'm going to go ahead and run that again. I expect the test will still fail here. We're not done. But I just want to make sure we're getting in the latest dependencies. Sometimes what I've seen is VS Code can get out of sync with Gradle. So in order to fix that, and it's good to show, you can open the command palette on Mac, that's Command-Shift-P, and then say Java, clean Java language server. This is basically going to reload everything. And hopefully this will be happy now with my imports. We'll give it a second to load Gradle in Java. Okay, Java's ready. That's happy. The last thing we need to do is in our tests, we just need to tell it to import that class. Oops, and actually that was giving me a useful error message. It goes on the class, not on the method. Okay, with that, let's go ahead and run another build. All right, the build is successful. So now we have our tests running with test containers, which is spinning up PG Vector or Postgres as a container. And we have our development, as I said, running with Docker Compose so that we have our images there. And this is how you add RAG to your Java Spring Boot application. So thank you for watching. I'll see you on the next one.